Now, thermistor is a kind of resistor whose resistance depends on temperature. Uh, it is a variable resistor, but unlike simple variable resistor whose resistance is changed manually, thermistor's resistance depends on temperature. A negative coefficient thermistor will be the one that we will be most commonly discussing. A negative coefficient thermistor is the one whose resistance will decrease when we increase the temperature. The graph shows how the resistance varies with the increase in temperature. So when temperature increases, resistance decreases. And I hope you can clearly see that it is opposite to what normal conductors do. In normal conductors, when heat energy increases, resistance increases. But only for uh, thermistor, it is opposite. I think I have lost my screen. Just 1 second. Okay, back live again. Now, for thermistor, when temperature increases, resistance decreases. But in case of the next semiconductor, LDR, when we increase the intensity of light or intensity of electromagnetic waves that fall on that LDR, the resistance decreases. These kind of LDRs, they are very commonly used in sensors which supposed to indicate any variation of intensity of light. For example, the proximity sensor that is in your mobile phone, it increases or decreases the brightness of the screen of your mobile phone because of the change in brightness around you. Now, LDRs can also use to detect presence of invisible light, invisible electromagnetic waves. For example, you can also use it to find out the presence of infrared or microwaves or ultraviolet or X-rays. So all you have to do is just make a circuit, use this as a sensor, so it can detect any electromagnetic waves. Now, when we increase the intensity of the light or intensity of the electromagnetic wave, resistance of the thermistor decreases. So they both are negative coefficient, negative correlated. They both are negative correlated. Thermistor has a negative correlation between resistance and temperature, and LDR has a negative correlation between resistance and intensity of light. The third kind is a diode. So a diode is something that only allows current to go in one direction. When current goes along the direction that diode allows, the diode in that situation is called a forward bias diode. And diode makes sure that current only go through in one direction. Okay. If direction of current is allowed by the diode, that is a forward bias diode. That situation is called forward bias. And if current is opposite to the direction that diode allows, that is a reverse bias diode. And in that case, diode acts like an open switch, like a very high resistance, infinite resistance, for example. So the graph shows the variation of the resistance with variation in the polarity. In one direction, current is allowed. In the opposite direction, when potential difference changes direction, there's no current passing through. So such materials are called diode. Their job is to make sure that the current is going in a circuit in one direction. If current changes direction, they turn off this the whole circuit. Okay. Any questions? Okay. I hope you remembered these kind of questions. But previously we were doing them with manual variable resistor. But this time we are doing it with a thermistor. Question is, read the question carefully. State and explain changes, if any, to the brightness of lamp X1 and X2 if the temperature of the thermistor is increased. What will happen to the brightness of lamp X and lamp Y, or X1 and X2, when we increase the temperature? The thermistor is, if temperature of thermistor is increased. So if we increase the temperature around the thermistor, what will happen to the brightness of lamp X and lamp Y? Who can answer the question? No one.
Sir, can I tell?
Sorry?
सर आपको आवाज आ रही?
Okay, now it is the same kind of question, but in this case, instead of using a thermistor, there's an LDR. Two lamps, X1, X2 are connected. These two lamps have same resistance in any case. Their resistance will not change because of change in anything around them. They are fixed resistances, and there is an LDR. LDR's resistance depends on intensity of light. Question is, state and explain change, if any, to the brightness of lamp X1 and X2 if the intensity of light is increased. What will happen if we increase the intensity of light near the LDR? Which lamp will become brighter, which lamp will become dimmer, which lamp will stay the same, and why? That is a 4-mark question. Write on your answers again and share them in WhatsApp. With the increase in intensity, there will be decrease in resistance. So less potential difference for LDR and for X1, which is lamp X1. This will make lamp X1 less brighter. As EMF is fixed, there will be more PD across lamp X2, which will make X2 brighter than before. And this is because brightness of lamp is a function of power, and power equals to voltage multiplied by current. When we say brightness of the lamp, actually we want to describe the amount of power developed in that lamp. Similarly, speed of motor means power dissipated in motor. Okay. Now, potential divider. If we have four resistors as shown over here, and we have done this kind of question before, where we calculated potential difference between V1 and V2. But in that case, I did not make the special case where the resistors have same ratio, same ratio between R1 and R2 and R3 and R4. In that would be a different case. But right now, if we have this situation and we have voltmeter connected between V1 and V2, which are 2 points on two different loops, two different parallel loops, R1 containing R1 and R2, the other one has R3 and R4. If this voltmeter reads 0, if there is no potential difference between V1 and V2, the normal mind says that it can only be possible if R1 is same as R3 and R2 is same as R4. But that is not true. Like if they would be same, yes, there will be no reading on voltmeter. But the thing that has to be same in this case is the ratio. For example, if R1 is 100 and R2 is 500, then we will get this reading 0 if R3 and R4 they have same that 1:5 ratio as well. Like it can be R3 is 1 and R4 is 5, or it can be R3 is 200 and R4 is 1000. If R3 and R4 have same ratio as R1 has to R2, then the reading on voltmeter will be 0. So this is a particular setup where voltmeter is 0 and we can establish an equation. It means R1 divided by R2 is same as R3 over R4. And the equation can be R1 over R3 equals to R2 over R4. This equation can be applied in two different ways. And we will resume from the same point tomorrow. The end for today.